Okay, so in this video I'm going to show you how to solve these guys. What time does it spend going up? What's its initial velocity and how high did it go? To do that, we're going to go from the ground to the top. It stays in the air for 7.48 seconds, right? So what we can do is we can divide that in half. We know that it's going to spend 3.74 seconds going up and 3.74 seconds going down, okay? Because it spends half the time going up and half the time going down. You can do that whenever it starts and stops at the same elevation. It leaves the ground, hits the ground. You can't do that if you're talking about like at an elevation of 50 meters or something like that, right? But if it's symmetrical, you can divide the time in half. So just divide that by 2. You get 3.74 seconds, right? And now we can set up a, now we can go X, VI, VF, A, and T. And we're going to go from the ground to the top, okay? Well, from the ground to the top, we know that the acceleration is negative 9.8. We know that the time is 3.74, right? And then we know the velocity at the top. The velocity at the top is 0, because if it's not 0, it's just not at the top, is it? Right? And so now let's see, we can solve for this. This will be the height, this will be the initial velocity, okay? And then time spent going up, you just take the time and divide by 2, right? So to find the initial velocity, I'm going to use, let's do that one first. Divide the space in half here. I'm going to use VF is VI plus AT, right? So 0 equals VI plus negative 9.8 times 3.74. Right? And then if I solve that, let's get the trusty calculator out here. What's going to happen here is, notice that this is negative, but I put it on this side, it becomes positive. So VI is going to be a positive number. 3.74 times 9.8. 36.652. Okay? Alrighty. So that's my answer there. That's our answer right here. Okay? So positive 36.7, I guess you'd round that up to, you have 3 digits here, you'd round that to about 36.7. Okay, so now to find the x, I could use any formula I want. I guess we have to use this formula. I'm going to use, what am I going to use? I'm going to use this guy. VF squared equals VI squared plus 2AX, right? So 0 squared is 36.652. Notice I'm using the unrounded value that I got, not this. Okay, and I'm going to square that guy. Plus 2 times negative 9.8 times x, right? So 36.652, I'm going to square that. And I get 1343.369, right? Is 2 times negative 9.8 times x, right? And now what I do is I just divide this by 2, divide it by 9.8, right? Oh, this is negative because I put it on this side, right? And the negatives are going to go away, yeah. So I divide by 2, divide by 9.8, and I get 68.53924. So I'll go 68.539. Right? So 68.5 meters, we get the height that it goes to. Okay? Now, as an added bonus here, I can also tell you what its final velocity is. Okay? When they say final in this context, right, they're talking about it hitting the ground. Now, we cut it in half, right? We said the final velocity is 0 at the top. But when here they say final velocity, they actually are talking about the final velocity when it strikes the ground, right? So we can use another trick, and the other trick is that if this is positive 36.7 leaving the ground, and there's no air friction, then it's going to hit the ground with the same speed. It hasn't lost any energy, right? So negative 36.7 is what it's going to hit the ground with. Same speed up, same speed down, but the velocity is different because it starts out going up and ends up going down, okay? In the next video, I'll explain this thing here. Okay, and we're going to use this 36.652 in the next video. Okay.